Now, let's analyze the problem of the business. The first problem is staff accommodation. As shown in the map on the left, there are three branches of the restaurant. Two branches are within 1 kilometer of each other, but third branch is 3 kilometers away from branches 1 and 2. For the staff working in each of the branches, the company provides condominiums beside their working branches. We call it condo A, B, and C. Each condo has various rental fees and transportation costs to reach each branch. Our scope is to minimize the total cost of rent and transportation by assigning different condos to the staff. And we assume that the number of staff has no change, accommodation cost is stable, employees fully follow the company's decision, the room number is unlimited, and 1 month has 31 days, and staff get a holiday of 4 days per month. In terms of limitations, staff satisfaction for condominiums, hiring and firing staff, and external factors for transportation are limited in accounting. Next is management science technique, which we use the linear programming. In terms of mathematical formulation, our objective is to minimize z. There are 12 decision variables and 4 constraints as shown on the left side of the screen. Next is parameters. As we mentioned earlier, there are 3 branches and 3 condos. The total number of staff working in branches is 23. In terms of the condo fee per month, condo C has the highest price and condo B is the lowest. And the travel time and transportation fee are as shown on the right side. Now it's decision variables. According to the solver, the optimal solution is to move all staff living in condo A to condo B, which makes condo A empty, and use only condo B and C. These will greatly help to reduce the non-cost management burden, such as ease of control, lower maintenance cost, and reduced utility expenses. For the number of rooms, it will be changed accordingly. Let's shift to constraints. There are 4 constraints. Unlike condominiums A and C that maximum of 2 people can use one room, condo B has a bit bigger room size, which allows 3 staff to live in one room. Same number of staff, but fewer rooms needed. For the average travel time, each of the branch workers should not spend more than 10 minutes, and all the decision variables should be integers, as it is a number of staff and rooms. Lastly, the total staff in the decision variables should be equal to the number of required staff for each branch. Now is the result. With the optimal solution, we can save 2,600 baht per month with the new change, in percentage 3.5%. And if you look at these over the year, we save 31,200 baht per year. Next scenario. When we move the room, we need to consider the contract as well, because we can lose the deposit when moving rooms during the contract. Let's say we move all the staff from condo A to B. We will have an unreceivable refund of 13,200 baht. However, we will still reduce the cost by 18,000 baht because the cost reduction per month is much higher than the deposit. How about waiting until the deposit receivable month, February? We will not lose any deposit, but the saving cost is just 15,600 baht, which is less effective than the immediate change. Another scenario is moving all staff into one condominium to reduce the management burden at the highest level by using only one condominium. What we can notice here is that putting all staff in condo A has the highest total cost, while putting all staff in condo C has the highest average time. Finally, is the analyzing part. Among the immediate change and gradual change, immediate change is the best and better choice, although you will lose the deposit, as the monthly cost reduction by changing the condominium is much higher than the deposit. For putting all staff in one condominium to reduce the management burden, condo B is the best decision as it has the least extra cost and travel time. But overall, immediate change is still the best choice regarding cost matters.
Running a Korean barbecue isn't easy, but knowing how much pork you should stock up on is even trickier. With issues like fluctuating prices as well as capacity to take into account, this makes it hard for buffets to decide how much they should order. Sometimes the restaurant runs out of pork before the days even end, or some other time they overstock and have too much pork left over, and that's just money wasted. So, how much pork should the buffet order every month is the question, and that's where linear programming comes in. The buffet was restocking based on gut feeling alone, or last month number. That's not exactly scientific, is it? And the result of that? Unpredictable cost and waste. To help the buffet, we use linear programming, with the goal being to minimize costs while meeting customer demand, respecting cold storage capacity and delivery capacity. But before we get deeper, every model has its boundaries. That includes assumption, limitations, and its overall scope. For the scope, the model focuses specifically on monthly pork restocking for the buffet. It is built to minimize costs while meeting demands and managing storage and delivery limits. To keep the model simple and usable, we also need to make a few assumptions. We assume that customer demand stays consistent based on past trends, with each customer consuming 2 serving each. The freezer capacity is also fixed at 360 kilograms throughout the planning period, with one freezer storing 120 kilogram each and each branch having one freezer, adding up to 360 kilogram total max storage. Order must also fall within a practical range from minimum of 10 kilograms to a maximum of 300 kilograms per order, with each delivery having no delays. We also assume that all pork remains usable during storage with no spoilage or waste, making inventory tracking much simpler. And of course, no model is perfect. Therefore, there are some limitations to what this approach can do. One of the first limitations is that we cannot know the exact amount each person eats, since everyone consumes a different amount of pork. The model also relies on historical demand data, which may not fully capture the shift in consumer behavior or the trends in this current year. We assume a stable price of delivery with the cost of 300 baht per order, but in reality, these can change unexpectedly. Revenue is also excluded from the model since our main focus is for cost optimization. And lastly, we don't account for issues such as supply delays, unexpected spoilage, or poor quality changes. Now that we've outlined what the model assumes and what it doesn't cover, it's time to see how everything else comes together.
To start a model, we input real data from the owner, which are the fixed input to driving our model. This includes the demand or number of customers in monthly, like 492 customers in January. We also have the list of pork cuts we need to order providing with their price in the market and pork cuts requirement distribution. Moreover, we also have freezer capacity of 360 kg in total, split as 120 kg per branch, plus a fixed transportation cost of 300 baht per order. Lastly, we also have the price fluctuation table that tells the change in price of each pork cut in a specific month. Next is the decision variable where we can take a control. The first decision is the binary decision to decide if we make an order or not in that month. And next are the amount of each pork type to order monthly, ranging from a minimum of 10 kg to a maximum of 300 kg per order. For example, we decide how much belly or neck to purchase in January to meet demand while staying within limits, which allow us to optimize inventory effectively. And these are the results after we solve. For example, the owner should order 123 kg of pork belly in January to minimize the total pork purchasing cost. Next is the constraint to keep our model realistic. First is the freezer capacity, which the total pork in the inventory must not exceed 360 kg across all branches to ensure we don't overstock. Next is the minimum and maximum quantity when we order. Each order must stay between 10 kg and 300 kg. Move on to the demand constraint. For each pork type must be fully met each month. The demand of each cut will be different due to the preference of consumer. And lastly is the binary constraint, where we decide which month we will order the pork or not.
Alright, let's dive into the results of our pork inventory optimization for 2025. And trust me, this is way more exciting than it sounds because we save money like a lot. So using our linear programming model, we managed to cut inventory costs down to 494,000 baht. That's a saving of 44,000 baht from the original cost of 520,000. So now you might notice, yeah, the costs were a bit higher at the start. That's because we bought more pork early on. But here's the trick, we intentionally stock up when the prices were lower. That way, when price spiked later, thanks to things like inflation, weather, or sudden supply shortage, we were already prepared. So instead of buying expensive pork later, we used our early cheaper inventory. Okay, now let's talk scenarios. We tested three: fewer customer, shifting demand, more customer. And we added price swings from -3 to +3% just to keep things real because in the real world, stuff changes fast. So what happened in each case? So if pork price go down and customer go up, that's great. We're looking at a cost of just 465,000. But in the worst case, price rising, customer dropping, we hit 493,000. Still manageable, but not ideal. And those 3% swing, they could be caused by anything like economic uncertainty, protests, social media trends, or just fewer picks on the market.